In this video, we start Activity 11, which is about congruence transformations and triangle congruence. Lesson 11-1 is about congruent triangles. The learning goals are to use the fact that congruent triangles have congruent corresponding parts and to determine unknown angle measures or side lengths in congruent triangles. Greg Carpenter works for the Green Construction Company. The company is building a new rec hall, and the roof of the hall will be supported by triangular trusses, like the ones shown below. Each of the trusses contains pairs of congruent triangles. Greg's boss tells him that his first job will be to determine the side lengths and angle measures in the triangles that make up one of the trusses. Greg wonders, if I know that two triangles are congruent, and I know that the side lengths and angle measures in one triangle, do I have to measure all the sides and angles in the other triangle? Greg begins by examining two triangles from a truss. According to the manufacturer, these two triangles are congruent, and hopefully these look the same size and shape to you. Number one, because the two triangles are congruent, can one triangle be mapped onto the other? And the answer is yes. That was the content of the previous lesson. If you can find a sequence of rigid motions that maps this triangle onto this triangle, then we know that they're congruent. And I think it could be as straightforward as reflecting triangle ABC to the other side of this line. It would land smack dab on that triangle. Number two, suppose you use a sequence of rigid motions to map triangle ABC to triangle DEF. Find the image of each of the following under this sequence of transformations. So segment AB, what does it map to? If we flipped this triangle over and landed it right on there, where does segment AB map onto? How about segment DE? How about angle A? What does that map to? Well, angle A is this corner, and when this triangle flips over, I think it would end up being that corner, angle D. How about segment BC? So this side here would correspond to this side here, segment EF. Notice that all of these questions in problem 2 are asking us to find the corresponding part in the other triangle that matches to this part in the first triangle. So angle B, this angle here, where is its corresponding part? Well, that would be angle E. And last, segment AC. That is the bottom of this triangle, and when flipped over here, it would become segment DF. And last, angle C. Which angle corresponds to angle C? How about angle F? Number 3, what is the relationship between segment AB and segment DE? So those two right there, those corresponding parts, they are congruent. And similarly, the relationship between angle B and angle E is that they are congruent. And the reason is because there is a sequence of rigid motions that map them onto each other. It's actually not a sequence of rigid motions. Again, it's possible in this case just to reflect it over a line that's running right down the middle there. Now, the triangles from the truss that Greg examined illustrate an important point about congruent triangles. In congruent triangles, corresponding pairs of sides are congruent, and corresponding pairs of angles are congruent. And these are called corresponding parts. So the idea is that corresponding parts are congruent to each other. Corresponding angles are congruent, corresponding sides are congruent. When you write a congruent statement like triangle ABC is congruent to triangle DEF, you write the vertices so that the corresponding parts are in the same order. So you can conclude from this statement that segment AB, use the first two letters, is congruent to segment DE, those first two letters. Or that segment BC is congruent to EF. BC is the last two letters in this triangle name. EF is the last two letters in this triangle name. That's true for the angles as well. Angle A is congruent to angle D. So using that first letter, its corresponding letter is the D. Those are congruent just from the names. Here's example A. For the truss shown below, Greg knows that triangle JKL, let me highlight that in brown, JKL, so this triangle, is congruent to triangle MNP. So MNP, this triangle, Greg knows that those are congruent. He wants to know if there are additional lengths or angle measures that he can determine. Well, since these triangles are congruent, their corresponding parts are congruent. So if this side here is 2.1 meters, then the corresponding side in the other triangle is 2.1 meters. Which of the three sides is that? And that's the NP. So Greg can know that NP is also 2.1 meters. See how over here it says that angle N right in there is 50 degrees. Angle N is 50 degrees. So the corresponding angle in the other triangle is also 50 degrees. So without measuring, Greg can know that angle K is 50 degrees. So this idea about corresponding parts being congruent in congruent triangles allows us to figure out unknown measures if we know some measures in one of the triangles. Here are some try these. In the figure, triangle RST is congruent to triangle XYZ. Again, pay attention to the order of those letters because they tell you what corner of the triangle corresponds to what corner over there. Find each of the following if possible. Can we find the measure of angle X? Can we find this angle? Well, it's congruent to angle R in the other triangle, but we don't know angle R. And so no, we cannot. Not possible to figure this angle out only knowing the 47 degrees. Can we find YZ? Can we find this length? Well, in the other triangle, its corresponding side is 15 centimeters, and so yes, we can. That is 15 centimeters. What about the measure of angle T? Can we find this angle measure? Well, we can, because its corresponding angle is 47 degrees. And last, can we find segment XZ? So this one right here. Can we figure out how long that is based upon the numbers that we have in this picture? It corresponds to this one here, but we don't know how long that is, and so no, this is not possible with only the numbers that we have in our drawing. Finally, question E. Both triangle JKL and triangle MNP are equilateral triangles, so the measure of each angle is 60 degrees. Can you tell whether or not they're congruent? And the answer is no. If all you know is that the angles are 60 degrees, 60 degrees, 60 degrees, and that the other triangle, its angles are 60 degrees, 60 degrees, and 60 degrees, that's not going to be enough information to know for sure that they're congruent because the sides might be different length. Here's an example. Here are two triangles where the angles are all 60 degrees, but they're certainly not congruent triangles. Here are some check your understanding questions, so I'll pause the video. In this lesson, we looked at the fact that congruent triangles have congruent corresponding parts, and we used that fact to figure out unknown angle measures and unknown side lengths when we had congruent triangles. If we knew the measure of a certain part in one triangle, then in the other triangle, its corresponding part would have that same measure.